Welcome to your Chapter 2 test review. For the first portion of this video, we will be going over problems that we went over in class, and then towards the end we'll get to the stuff that we didn't get to. So, first, identify your domain and range. So domain, yet again, is our set of x values. So I have 4, 4, 16, and 16, and I only need to write it once. So 4 and 16 is going to be my domain, and your range is your set of y values. So I look at all the y values. I have -2, 2, -4, and 4. That is all I need. You don't necessarily have to write the repeating values, but if you want to, I'm not going to take off for it. My second problem, identify my domain and range. So I'm going to write D6, -2, 1, and -2 again. I don't need to write that repeating -2. Can if you want. My range, -1, -3, 8, and 5. Okay, next problem. Is this relation a function? Well, Wyatt guessed in class yes, but how did he know? So yes is the answer. Yes is the answer. In order to determine if this relation is a function, I need to see if there's more than one arrow coming from a x value, or see if there's any repetition in the domain, if this was a set of points. Are there any points where x's repeat? So the answer to all of those questions would be no, there's no repetition in the domain, even though there is repetition in the range, but that doesn't matter. So it's going to pass the vertical line test if you were to plot these points. So this is yes, it is a function. Okay, graphing. So I need to be able to graph, and using my y equals mx plus b, I'm just going to go ahead and plot my point at 0, 1, 0, 1, my y-intercept is 1, and then this slope, -3/4, equals -3/4, it tells me to move down 3 and right 4. So I'm going to move down 1, 2, 3, right 1, 2, 3, 4. Okay, and just to, ooh, that was a bad line. Just to double check here, my slope is negative and my line is decreasing, so this should be what it looks like. Alright, I need to identify if a function is linear or not. So that means, can it be put into the y equals mx plus b form? Can it be put into that? This one, it's pretty explicit. Yes, that is. Absolute value, that's going to look like a v, so it is not. It is not. This one, it's a little bit backwards, but this one is going to be linear, so it can be put into this line. I would do that just by switching my mx here and my b. And x squared. Johnny, during class, told us that this is going to look like a parabola, and I know certainly a parabola does not look like line, so this one does not. So f of x and h of x are linear. Alright, I need to use function notation. In order to use my function notation, I see what my input variable is here. My input is x, so wherever there is an x, I'm going to put an 8. So 8 plus 15 is 23. I do encourage you guys to pause this problem and try it, and then go ahead and play for the solution, or fast forward for the solution. So wherever there is an x, I need to put a -3. I just put my -3 in my parentheses just to make sure. So I have -3 squared, which is the same as -3 times -3, so that's going to be a positive 9 plus 1 equals 10. F of x equals 6. So my input variable is x, however, I don't have any x's. So it doesn't matter what I'm putting into the equation, it's always going to equal 6. It's always going to equal 6. Alright, I'm going to need to be able to find my slope and determine whether it rises, falls, is horizontal, or vertical. So here I'm using y m equals y2 minus y1 over x2 minus x1. So I'm going to go ahead and do -6 minus 3 over 2 minus -4. Make sure your negative signs are straight. Otherwise, we're going to have some issues and you're not going to come out to the correct slope. So minus a negative, that's going to give me a positive. So I have -9 over 2 plus 4, which is 6. And reduce, -3/2. Next one, I have -1 minus 1. -1 minus 1 over 7 minus 7. So I get -2 over 0. Can I divide by 0? No, I can never divide by 0. So that means this is going to be undefined. Undefined. And if I were to answer my second part, a negative slope means I am falling. Falls. What's an undefined slope? Well, undefined means it doesn't work out. It's not going to pass my vertical line test, which means I'm going to hit more than one point at a time. So it's going to be a vertical line. Undefined slope is a vertical line. A zero slope is a horizontal line. Next one. I have these 2 points. Why don't you go ahead and try it out. You can pause the video anytime you need to practice. So I get -10 over -4. That's going to reduce to 5/2. And since it is positive, it is rising. Rising. It is a positive slope. Last slope example. So -2 minus a negative is a positive. -2 plus 2 gives me a 0 on top. 0 divided by anything is 0. Since I already know an undefined slope is a vertical line, a zero slope is going to be a horizontal line. Horizontal. Now I'm moving on to a little bit more difficult problems that involve a couple more steps. So if I give you a couple sets of points, I need to determine if the lines are parallel, perpendicular, or neither. So I'm just looking at several points here. I think I'm going to go ahead and try to find my slope. Slope of my first line. Alright, 2 minus -2 gives me -12 over 4 is a -3. That's the slope of my first line. -3. Then if I take the slope of my second line, 2 minus 1 over -2 minus -5, 1 over 3. So I'm looking at 1/3 and -3. Are they opposite reciprocals? Yes, they are. So that means they're going to be perpendicular. Perpendicular. Since they're not the same, I know they're not parallel. And so then I would check if they're opposite reciprocals. That would be my next move, and they are. So this was a challenging one for you guys. If I give you your slope, so I already know right away my slope is going to equal 2. However, I don't have one piece. If I don't have one piece, I should be able to solve wherever that variable is for that variable. So Mr. Johnson, I believe, tackled this problem. So he did 7 minus -3 over k minus 2 equals -2. And then I would get 10 up top, k minus 2 equals -2. You could multiply both sides by k minus 2 and get 10 equals Negative 2 times k minus 2. Use your distributive property here. Or divide both sides by negative 2. I'll go ahead and do that. And get negative 5 equals k minus 2. K should equal negative 3. I did get a couple questions during class. Can I graph this? If I graph it and find what k equals, is that fine? That's absolutely fine. However, your hand-drawn graph may not necessarily be that accurate, and it also just may take up more time than using the algebra. This is Algebra 2, so I would like you to do the algebra. What is the formula for slope-intercept? My formula is y equals mx plus b. Now, I'm not going to ask that on the test. I'm just asking you for this review. You should know that. This should be memorized. Should be memorized. You should know that. I think you do. Alright, so we're using a lot of lines here. You're going to need to be able to graph these. So I'm going to go ahead and draw my graphs for all of these. Okay, my technical B here, my starting point is going to be 0, 0, the origin. This looks like a direct variation. And my slope tells me to go down 1, or down 2, and right 1. So I should have a negative slope. This one tells me that my B is 3. So I should be starting the y-intercept and going up 1, right 1, because my slope is 1. And last but certainly not least, my b in this situation is 1, and my slope is negative 3. I can always put that over 1 so that I know how to move. So I'm going to be starting at 1, going down 1, 2, 3, and right 1. If I'm double checking, my slope is negative and my graph is decreasing from left to right, so it works out. Alright, standard form. This should be memorized, so you should know what this looks like. ax plus by equals c. Now I have to keep in mind, I told you guys that a, b, and c cannot be fractions. Are not fractions. And also, I want a to be positive. A is positive, because I don't want to start out on a bad foot. That's just how it is. They don't tell you that explicitly in your book, but I gave you those directions. Okay, so if I were to graph, this is currently in standard form. I did have a couple people go ahead and solve for y because they wanted to put it into their slope-intercept form, and that's perfectly fine. You can do that. If I did that, I would get this is what I would get, and so then I would plot 0, 5 and use my slope. If I didn't, I could find my x-intercept right away and my y-intercept right away. I know since I'm lying on the x-axis, my y is going to be 0, and for this one, since I'm lying on the y-axis, my x is going to be 0. So I can go ahead and plug in 0. If I plug in 0 for y, that kind of marks out that 2y right there. So then I get 5x equals 10. 5x equals 10, so x is going to equal 2. If I plug in 0 for x, I get 2y equals 10, so y is going to equal 5. So from there I get 2 points. 1, 2, 3, 4, 5. 2 points, and there we go. That's what it should look like. And if I look at it, that fits that graph as well. Find my x and y intercepts. It's very similar to what we just did on the last problem. So x-intercept, I know my y is going to be 0, And for my y-intercept, my x is going to be 0, so I need to plug in those values. So if I plug in 0 for y, I get negative 6x equals negative 36. So x is going to be 6. And if I plug in 0 for x, I'm going to get 8y equals negative 36. I'm going to divide both sides by 8 and get y equals negative 36/8. That's going to reduce to negative 18/4, which equals negative 9/2. So you could give me negative 9/2 or negative 4.5 is perfectly fine. Put 2x minus y equals 10 into slope-intercept form. So you guys are going to need to be able to manipulate all of these different forms. And in order to do that, I know that slope-intercept, I should end up with a y equals something. So I need to move my x to the other side. So I'm going to go ahead and subtract 2x from both sides. Get negative y equals negative 2x plus 10. And then I need to divide by that negative 1 in order to get my plain y. So when I do that, that flips my signs. 2x minus 10 is your final answer. Write the equation of a line with the given slope and the y-intercept. So that means I'm just going to plug in what I know. Well, I know my slope and I know my y-intercept. So y equals negative 3/4 x plus 7. That is my final answer. What is point-slope form? So if I give you any point on this line and a slope, you should be able to plug it into this formula and figure it out. So I have y minus y1 equals m times x minus x1. And the three parts where you'd be plugging in is for this point, x1, y1, whatever it is, and whatever your slope is. These are the pieces of information that you're going to be plugging in. And then eventually you can solve for y. So, write an equation of a line that passes through 5,4 with slope negative 3. That means I'm going to be plugging in. Keep in mind, it is minus, so if this is a positive, it should still be minus. So y minus 4 equals negative 3, x minus 5. Make sure to keep those signs straight. So then I would have to use my distributive property. Y minus 4 is negative 3x plus 15. Then I would have to add 4 to both sides. Y equals negative 3x plus 19 is your final answer. Find the equation of a line that passes through this point. So I have this point, so I know that it's going to be y minus 8 equals, I don't know what my slope is yet, x minus 2. So let's look at the rest of this. Is parallel to this line. Well, I know if they're parallel, I should have the same slope. So if my slope is 3 for this line, I know for my new line, my slope needs to be 3. So I'm going to go ahead and plug in 3 down here. So, using my distributive property, y minus 8 equals 3x plus 6, minus 6. Minus 6, and then I have to add 8 to both sides. Y equals 3x plus 2 is your final answer. Whenever I ask for the equation of a line, I'm going to want it in y equals mx plus b form. Okay, equation of a line through 4, 1. So I already know my point. I don't know my slope, x minus 4. And it is perpendicular to 1/3 x plus 3. So my current slope is 1/3. So I know that since it's perpendicular, my new slope is the opposite reciprocal. So that means I need to flip it. So it's going to be 3/1 now, and I need to change my sign. So it's going to be negative 3/1, which is negative 3. So this is my new slope, which I can put in right there at m. So negative 3. Y minus 1 equals negative 3x plus 12. Because a negative times a negative is a positive. And then I need to add 1. Here's your final answer. Well, what if I only give you 2 points? Well, if you have 2 points, you should be able to find the slope. So let's go ahead and do that. 9 minus 3 over 2 minus negative 1. Make sure you're consistent with your first point and second point. And y's over x's. Change in y over change in x, always. So I get 6 over 3, 2. So here's my slope. And which point do I want to use? Well, it doesn't really matter. I'm just going to go ahead and use this one because they're a little bit smaller numbers. So I get y minus 3 equals 2. And x plus 1, since I have minus and negative 1. So, distributive property here, 1 minus 3 equals 2x plus 2. Y equals 2x plus 5 is your final answer. Alright, direct variation. Now this is the new portion that we did not get to. So direct variation, in your book, apologies, in your book it has y equals ax, y equals ax. So, x and y vary directly. That's a cue. I should have something using y equals ax. And x equals 4, y equals 8. What's the constant of variation? So if I were to solve this, a equals y over x. Y's over x's. It's just like your slope. So 8 over 4. 8 divided by 4 is 2. So there you go. A equals 2. Write an equation. Write an equation is my next step. So I would simply just plug that back in for a. So y equals 2x. Well, when x equals 7, what does y equal? Y equals 2 times 7, 14. So here are your 3 answers, 2, y equals 2x, and 14. Okay, is this a direct variation? So if I give you a table like this, you're just going to go ahead and look at your x values and your y values. You know that for every single one, you should come out to the same a. So 7 divided by 1. 7 divided by 1 should equal 9 divided by 2, should equal 11 over 3, should equal 13 over 4, should equal 15 over 5. Right away, if I'm looking at my first one, 7 divided by 1 is 7, 15 divided by 5 is 3, I've got a 4.5, none of this is equal. None of these are equal. So this does not work out well at all. So is this a direct variation? No. No, it is not. No, it is not. If I were to give you an example of a direct variation, x, y, 8 over 4, 16 over 8, 4 over 2, any of those, my constant would equal 2. I would take 4 divided by 2, 16 divided by 8, and 8 divided by 4, a equals 2. So this one would work out. That would be an example. Write a direct variation. Well, if I know my equation, it should be memorized, should be set to heart. Y equals ax. I can plug in my y and my x. So I can divide both sides by 3. A equals negative 3. And therefore, my direct variation would be y equals negative 3x. Okay, correlations. Here's really the only piece of information that I'm going to need you to know. You just need to be able to identify these correlations graphically. So If you have a lot of dots that are rising from left to right, that's going to be a positive correlation, and since these data points are fairly close together, their correlation coefficient is going to be 1 if it's close together. Remember, our range is -1, -0.5. 0 means no correlation, 1/2, and 1. So these are going to be fairly tight together as far as the data points are concerned, and these ones going to be a little bit further apart. So if I were to compare this first graph with this second graph, clearly these dots are a little bit further apart on my second graph, so I would go ahead and label that one as a -1/2 because it's decreasing, and you would be able to draw that line of best fit, and there's no correlation on my third graph. Here is the tricky stuff. So, if all else fails, and I ask you to graph these, what can you do? You can draw a t-chart. You can absolutely draw a t-chart. Give me some x values and some y values. So, I'm looking at this, and I have y equals -1/2 x plus 2 minus 1. So I have a couple things going on. I need to address this, and this, because here's my parent function, y equals the absolute value of x, and these are the parts that change. So I know outside, this is my h, this is my k, and here's my a. This k, it's going to move me down 1. This negative, this being negative, is going to move my start point down 1. Well, this h inside, it should be a x minus h on the inside. Since it's positive, I know that technically this is a -2 right here. So that -2 is going to move what was down 1, it's going to move me left 2. So my new vertex should be at -2, -1. That should be my new vertex. And this A tells me a little bit about how my slope of my right side is going to change. So since it is negative, that means I'm going to be flipping my original graph over the x-axis, so it should be facing downward somehow. And I told you guys to look according to your right side. That is going to perfectly replicate what that A value is going to look like. So I'm going to be going down 1 and to the right 2. And I'm going to be doing the same thing if I were to say down 1 and over 2 on the other side. So it's going to reflect that. It's going to be symmetric. So this is what your graph should look like. Your vertex should be -2, -1. And I would say a couple things about this. I reflect over the x-axis. My new vertex is -2, -1, and you could tell me I moved down 1, left 2. And then what happened to my, let me redraw this a little bit better, what happened to my graph? How did it also change? I had a vertical shrink of 1/2. Go ahead and give me that number. So you could also say, if you decide to say a horizontal stretch, stretch, you would have to say times 2. That's where it's going to be a little bit different. Okay, if I am looking at 5x minus 2y is less than or equal to 6, is 0, -4 a solution? So what am I going to do? I have an x value. I I have an x value right there, and I have a y value right there, x and y. So I can go ahead and plug those in. So 5 times 0 is 0, minus 2 times negative 4, which is a positive 8. Is that less than or equal to 6? Is 8 less than or equal to 6? No, it is not. So that's not a solution. No, not a solution. What about negative 3, 8? So I get 5 times negative 3 minus 2 times 8. Negative 15 minus 16 less than or equal to 6. Is negative 31 less than or equal to 6? I think so. This is a solution. This is a solution. Yes. And last, but certainly not least, if I give you an inequality, I need you to be able to graph that. So, less than or greater than, that means I need a dotted line. Less than or equal to, greater than or equal to, I'm going to need a solid line. And if it is greater than, of any sort, greater than or equal to, you're going to be shading above or to the right. And if it is less than or equal to, you're shading below and to the left. So how do I graph this? If you look at it in standard form, which that's fine, you can find your x and y intercept that way, or you can solve for y and put it into slope intercept form. Most of you are probably going to make that move, so I will do that. So now I'm going to be starting at 1, 2, 3, 4, 5, 6. Here we go. And my slope tells me to move down 2 to the right 1. Okay. If I were to do standard form here, I would go ahead and put in zeros for my x's and y's. If I put 0 in for my x, my y is going to be 6. And if I put 0 in for my y, my x is going to be 6. So there are a couple points to graph. And it says that y is less than this. So just to make sure, I'll go ahead and plug in 0, 0 as a test point, in case I don't know. So if I put in 0, 0, that drops out. 0 is less than 6, so this works out. So wherever 0, 0 is, I need to be shading that side of my graph. And that concludes our review video. I would go ahead and work through at least one problem. Pick a problem per section. Pick a problem per section in your book. There's a review at the back of the chapter. So every single look over the review. Look over your review at the end of the chapter. Pick problems in each section. Pick problems in each section. You should have your homework. You should have your homework and those solutions. You can also use odd problems in the back of the book in which you have those solutions, and work them out and see if you have any questions. If you have any questions, email me. I'll answer. All right, well, good luck studying.